Hey everybody, it's Dr. Wood, and today I want to cover Chapter 7, looking at different types of measurement systems and how they are used for medications. So first off, the majority of everything you're going to be doing in medicine should be done by the metric system. You find there's some exceptions to that, but for the most part, this is going to be used pretty much as the standard across just about any realm of medicine that you go into. And so we're going to have three basic units you're going to be dealing with. For weight, you're going to be using the gram, which is usually abbreviated as just G. For volume, we're going to be working with liters, usually denoted by uppercase L. And then length is generally going to be in meters. Again, for pharmacy, you're going to use this less frequently, but certainly weight and volume are two of the very common ones you're going to be dealing with on a routine basis. So looking at some common prefixes, if something is a kilo something, that means it's 1,000 of one of those. So when I say, for instance, a kilogram, it means 1,000 grams, okay? If I say deci, that's going to be 1/10 of a unit. So a decigram is going to be 1/10 of a gram. A centigram is going to be 1/100th of a gram, right? Milli is going to be 1,000th, and then micro is going to be 1/1,000,000th. Okay, probably the most common ones you're going to be dealing with are going to be micro, milli, and kilo. Those are very, very common, but every once in a while you'll be dealing with deci and centa prefixes when you're dealing with the metric system. And again, here's a nice chart kind of walking you through the different prefixes and sort of what unit of basic measure they're going to be looking at. So for instance, here when you're saying just 1 liter, that's the base unit there. But if you had, say, for instance, a deca unit, it would be 10 of that. A hecta unit and a kilo unit. Again, these two are not going to be done all that too frequently, but certainly a kilo unit is going to be done all the time, right? So for instance, a kilogram, 1,000 grams. We hear that all the time. With deci, it's going to be 0.1 of a unit. With centa, it's going to be 1/100th, so it's going to be 0.01. For milli, it's going to be 0.001, and then for micro, 0.000001 of a unit. Okay, so very, very small amount. So when you're looking at common metric units used in medicine, as I mentioned, kilogram is going to be the standard for how we weigh our patients. We'll talk about pounds a little bit later on, and something you should be do if working in medicine is be able to convert from pounds to kilograms and vice versa. Because very frequently, for example, I have a patient who will come in, say a very young patient, into the peds ER, and the parents say, oh, the child weighed, 18 pounds and so many other ounces. And so it's our job to convert that over to kilogram, because the standard for dosing in anything in medicine is by dosing by kilograms, right? So again, very important to understand that. So mentioned the gram is going to be the common unit there, but certainly you're going to see milligrams used all the time. That's going to be denoted by mg. Kilograms by kg, and then micrograms by mcg. Now, occasionally you might see this being used as an alternative to micrograms. You might see something like this. That's not used anymore. That is basically, it's an unapproved abbreviation because it gets misread sometimes as other things, other values. Again, you can tell by my poor handwriting, who knows what that looks like. It looks like UG to me. But basically, MCG is going to be the standard for how we're going to be denoting micrograms. In terms of volume or liquid, liters is going to be a pretty standard one we're going to use very frequently. And then milliliter, which is going to be 1/1000th of a liter, is also very frequently used. So this is normally denoted by a lowercase m and then the uppercase L. Okay, so milliliter. So if you had 1,000 milliliters, that's going to equal 1 liter, right? And then in terms of length, centimeters can be used occasionally. Millimeters, again, used occasionally. Meters typically is going to be referring to how most people are in terms of their height. We'll use centimeters for height in children quite frequently when we're doing certain calculations. It just depends on kind of what the clinical setting is. So some handy conversions to remember for your sake there. Again, 1 meter is equal to 39.37 inches. This is not as useful here, but one I use quite frequently is looking at 2.5 centimeters is equal to 1 inch. If I have a patient comes in and they say that, oh, I'm 6 feet tall, being able to convert that over into centimeters if I'm using it for certain drug dosing is quite important, right? So we know there's 12 inches in a foot, right? And they say they're 6 feet tall, so I can do 6 times 12 equal to 72 inches. And then I can take that 72 inches, multiply that by 2.5 centimeters per inch, and now I know that patient is 180 centimeters high. or tall, right? And so that can be very useful for certain dosing, especially like a chemotherapy. We use it, oftentimes we'll use the patient's height and along with their weight in order to calculate their drug dosages, so it's very, very exact, okay? Again, if you had 1 meter is going to be equivalent to 1,000 millimeters. 1 meter is also equivalent to 100 centimeters, and then 1 centimeter, as it stands by this reasoning here, is equal to 10 millimeters. So this is ones that are used much more frequently in terms of pharmacy and drug dosing and things like that, and so it's good to know some of the common conversions in the metric system. So some things to know here, and again, sometimes these values get a little off kilter. I'm trying to simplify it for you to some degree. But one thing to remember is that 1 liter is roughly equal to about 33 ounces. 1 liter is also equal to about 1 quart, and if you think about 1 quart being a quarter of a gallon, about 4 liters is equal to 1 gallon of volume of liquid, right? More commonly, we're going to be looking at it in terms of 1 liter is also equal to 1,000 milliliters. So if you say, hey, go hang a liter of saline on that patient, that's 1,000 milliliters of that fluid you're giving that patient there. Also, it's good to note that cubic centimeter is equivalent to milliliter. They're the same value essentially. So if you ever say, give the patient 3 cc's of epinephrine, that's saying 3 mLs of epinephrine. It's the same thing essentially, right? So there's a 1-to-1 conversion here. Other important thing to remember here is that 30 mLs is equal to about 1 ounce. Okay, so it's a handy conversion to remember, because you may have a patient saying, I got 3 ounces of this medication, or I got 90 mLs. It's good to be able to convert that. A handy tip, if anyone was curious, or a handy bit of trivia, 1 standard shot glass is 1.5 ounces, or roughly 45 mLs, based off of that conversion there. This is a very handy one, as I mentioned, being able to convert pounds to kilograms. Now, 1 kilogram is going to be equal to 2.2 pounds. So, for instance, if you had a patient who weighed 100 kilograms, by converting this over, they would weigh 220 pounds, okay? Again, kilograms is going to be the standard for drug dosing for most patients, and oftentimes patients only know their weight in pounds because we live in America, and so we're still using that. Haven't fully moved over to the metric system, unfortunately, and so because of that, frequently patients will come in saying their weight in pounds. You got to convert it over to kilograms. Okay, 1 kilogram is equal to 1,000 grams. 1 milligram, but that means it's going to be equal to 1/1000th of a gram. And then 1 milligram is also equal to 1,000 micrograms. And again, this is not something we're going to be using very frequently because it is misread sometimes, especially when handwritten. So we also have these household measurement systems, and we're really trying to get away from this, but you're going to see it come up now and again, and it's important because this is kind of part of standard nomenclature here in the U.S., and so it's good to be able to convert these things over. And I'll tell you why this can be somewhat detrimental in some cases here. And so using kitchen measuring devices, and again, I don't know how great your guys' kitchen are, but I'm certainly not any kind of Gordon Ramsay over here, and so who knows how well calibrated all of my tools are, right? But some of the standard nomenclature you're going to hear there is including drops. Drops is going to be abbreviated as GTT. So again, if you're ever, say, writing a prescription for a liquid medication given in drops, you'll say GTT as the abbreviation there. And then 1 teaspoon is equal to roughly 5 mLs. 1 tablespoon is equal to 3 teaspoons, or 15 mLs. These are good numbers to remember, because very frequently a lot of medications, they used to say, hey, give 2 teaspoons, give a tablespoon. You need to be able to convert that into mLs. And then 1 cup is equal to 8 ounces. And if you recall, 1 ounce is equal to 30 mLs. So if you want to figure out how many mLs are in a cup, basically 8 ounces times 30 mLs per ounce, basically 240 mLs. So 240 mLs per cup. Okay. Now, again, we don't like to use this for measurement in medical facilities because of the different sizes of measuring devices. And so I talk about how if you were to, say, go and get a spoon from Walmart, say you get a teaspoon from Walmart, and then you go and get a Swedish teaspoon from IKEA, they might actually have very different volumes in them. Even though they're both teaspoons, quote unquote, one might be 4.5 mLs, one might be 6 mLs. That's not very standard, and so we can't get exact dosages, and so we've moved away from that for the most part. But you'll still hear it every now and then in medicine, and so you need to be able to make those conversions as need be. Okay, so as I mentioned here, 1 pound is equal to 16 ounces. And again, that's not fluid ounces like we were talking about in the last slide there. And again, this is usually abbreviated as LB. Ounce is always going to be abbreviated as OZ, as you can see there. Okay. And in general, 1 teaspoon is roughly equal to 60 or 75 drops. Again, this is very variable. So if this comes up on any kind of quizzes or anything, I'll give you that conversion there. We mentioned 1 tablespoon is equal to 3 teaspoons, and then 1 ounce is equal to 2 tablespoons, which makes sense because we said a tablespoon is roughly 15 mLs, right? 1 cup is 8 ounces. A pint is 2 cups or 16 ounces, right? So again, sometimes I'll say, a medication will come in a pint size bottle, right? Or if you go out to the bar, maybe get a pint of beer, right? So that's basically what they're trying to say is the size of that volume. A quart is roughly equal to 32 ounces, and then a gallon is about 128 ounces, or roughly equal to 4 liters as we saw before, okay? And again, there might be a little bit of wiggle room here and there, but that's roughly what we're looking at, okay? And again, length, again, not used quite so commonly in terms of pharmacology, but it does come up every once in a while. Again, if a patient comes up and they say, I'm 6 feet 3 inches, you need to be able to convert that to centimeters, as the case may be. Okay, sometimes medications get dosed in units, and so this is basically saying, well, we don't really express them as the weight of the medication, like it's not how many ever milligrams of the drug. We say a certain number of units, and that's based off of saying, well, this volume is going to give me this much strength of the medication or desired effect. So in the case of things like heparin, that gets dosed in units. Insulin is dosed in units. Penicillin G, which is an antibiotic, and vitamins A, D, and E, which are fat-soluble vitamins, frequently get reported as units. Okay, so it's not really the weight of the medication, it's more of the activity of the medication is how it's being dosed there. Now again, if you write U for units, that's going to be a non-approved abbreviation. You really need to write out units to avoid having any mistakes being made there. Okay. And then milliequivalence is going to be frequently used to describe the electrolyte content of solutions. So I see this most frequently for things like, say there's a mixture of potassium chloride or sodium chloride. You frequently will be seeing a dose in milliequivalents. And because again, it's just the standard dosing for those medications there. So oftentimes you're going to see milliequivalents per liter. So MEQ per liter is very common. So for instance, if I have, say, an IV solution that I'm giving, say I have normal saline, so you see NS as normal saline, and then it contains, say, for instance, 5% dextrose, so say D5%. And then oftentimes it'll contain KCl, which is potassium chloride, and it'll say 20 MEQ, which is 20 milliequivalents per liter. And that tells me that for every liter of that fluid of normal saline, which is sodium chloride and dextrose, I'm getting 20 milliequivalents. Okay, so it's very, very common. You're going to see that. Other ways to say it would be milliequivalents per milliliter, or perhaps milliequivalent per tablet. Say you had a KCl tablet or something like that. That would be done occasionally, but most often you're going to find milliequivalents per liter being the most frequent. And again, in terms of abbreviations and symbols, it's important to know what's kind of approved, what's not approved. And so the Joint Commission, which is an organization that accredits hospitals, they introduced this do not use list. And I recommend you Google that to find things that are commonly said, hey, don't use this. We talked about a lot of these already in a previous lecture here. But we talk about these because a lot of people still write medications inappropriately, and again, if you're in the hospital, this can be a big deal, because if the Joint Commission comes through and they do an audit and they're looking at this stuff and they see that someone's using these non-approved abbreviations, they can slap some pretty hefty citations on your hospital, right, which is no good. Also, not only that, there could be medication errors. That's why they became do not use abbreviations, because they saw there were errors happening because of them, right? So again, it's best to avoid those as much as you can. And so that's it for this section. If you have any questions, let me know, and I'll talk to you soon. Thanks a lot. Bye.